We just saw your dog.
Yes, the screen capture. Irish Wolfhound. Okay, I think we'll make a start then. Good morning, everyone. Welcome to the second session of the Internet of Things Capstone project. We're hoping now from this point on to start encouraging you as the learners to become more involved, a bit more active in what we talk about here. But we will go through a few basic things just on what we should be up to for this week, and then we'll open it up for discussion, see how people are going. We'll have a bit of a discussion on the deliverables which are due in the next couple of weeks. We've got a couple of examples from the previous edX programs to run through. So, just a reminder again, these meetings will all be recorded and posted to YouTube. So if you want to watch again, or you miss one, or you want to see what the other groups are up to, you can. And hopefully you can see this. This is the YouTube channel, and it's got the in here. And if you subscribe to this channel, you get a notification when we put the new ones up. I try to get them done within the day of them being recorded. Sometimes that might get a little bit delayed, but it shouldn't take too much longer. So everyone can see the YouTube channel. I'll take it away. Okay. Links to that channel are also on edX. There's one on the recording here, which is, I tried to shorten, I wouldn't, but you can type that link in if you wish. This session, we're going to have a look at what the requirements are for the next 2 weeks. And we'll run through that. You'll go through the requirements for the next 2 weeks. If you're having any issues with the Canvasser, please let us know, and we'll try and take you through some of that. I've already seen one student's Canvasser, and it is very impressive. They've done a wonderful job on it, and if they give me permission, I'll speak to them a bit later on. I'd like to point that one out to you as a really good example of what you can achieve with Canvasser as far as getting all of the specs down, getting the ideas of what you want to achieve, why you want to achieve it. And it is a rather good example. Next point is, has everyone received answers to their emails? I know there's still one outstanding which I've got to get to this morning. But if you haven't received an answer to your email, just remind us in the discussion after we finish this brief talk. I just want to make sure we haven't missed anyone. Make sure everyone's in a team. Obviously you are, but we've got to make sure that everyone is. So we'll be putting some announcements up or discussions up on anyone not in the team. And one thing I'd like you to do, which we actually haven't got in the requirements or as a deliverable, something to help with the motivation and identifying yourself with the project, is to come up with a name for your device or solution. So it's just something that when you're writing up, rather than writing my IoT solutions for measuring the traffic of snails across my vegetable patch, you can call it Snail Tracker. And it does help to identify it. It gives it a little bit more of a personal flavour, and it can act as a motivation if you come up with something nice and creative. All right, so if you do get a name, pop that up on the team board or in the discussion through the teams, so people can refer to your project by its new name. Okay, so what do we need to do this over the next 2 weeks? The first one is we need to work on Canvanizer. You will have to find the 3 problems that your IoT idea will address. This should be fairly simple. You'll know what you're trying to do, what the problem is, and how you're trying to overcome it. The real issue comes into tying it down into a small number of problems. Quite often we have issues where the scope of projects extends out and out and out. We need to have a very good idea of what the main issues are that you're trying to solve. Now, that doesn't mean that you shouldn't be ambitious and try to do lots and lots of things, but they should still only be solving that same set of problems. So when you have your feature set, that can be quite large, but make sure they still only address that small set of problems. By limiting the problems, you can limit the scope, but still allow for a roadmap through to add extra features as you come up with them, or as you get time, or as you wish to extend the application device. Morning, Sebash. Customer segments, so we need to know who you're targeting. For instance, my snail tracker, which would be a wonderful device for us veggie gardeners, would be aimed at home vegetable gardeners, the industrial, so we would know exactly who our target customers are, how much do they spend, why do they do, can we use a chemical or organic method. So we can narrow down into a very small group of people we would be targeting with this device. Probably want to a very well defined group of people to target our device at. So my snail tracker would be home veggie gardeners who want to grow their own organic vegetables and become self-sufficient without hurting the animals. So captures the snails and moves them off to someone else's property. So we would know very, very well what our customer target is. We need to know what is unique in our product, so our unique value proposition. Why is it different and why is it worth buying? Why don't I just go out and buy a packet of snail pellets? Well, because I don't want to actually hurt the snails. So there has to be some unique aspect to your device that you've identified, which will make it saleable to the customer base that you've identified. We need to have the top features of your IoT idea. Now, these are the ones that are the must-have. If you recall from the last session, I mentioned that when we're creating our set of desired features, we can create lots of features. There's no problem in doing that. Be nice and ambitious in what you're trying to create. But then we have to classify them. We have to classify them in what features are absolutely essential for this product to succeed. Then we have these would be nice, and if we get time, we will do them. And then we have the final set of requirements, which is one day perhaps we might get to do this. Okay, so we have those three stages. Now, you can still have a lot of features within those three stages. And the way you go about implementing them is you start off with the most simple or the most important features to implement. So I'll use the example of measuring the health of a guide dog. Guide dogs are really important. And a blind person quite often can't see what the dog is doing, and they can't easily check its temperature and look after the dog itself. So the most important feature is we want to look at the heart rate and the body temperature of the dog, and it would be nice to be able to tell if it's scratching its ear. To measure the temperature is very easy and it's critical, so that's the thing we would do first. To measure the heart rate is slightly more difficult and probably of a lower priority, so that's what we would do second. And as a final stage, we could use inertial measurement units and machine learning to identify if the dog is scratching its ear, and that's something we would do if we can later on. And that's the order you would implement things in. So find the top features of your IoT idea, work out what the priorities are for those ideas, which is absolutely critical, and what can be done quickest/easiest within those features, and start implementing there and work your way through the more difficult ideas that are still important, and then the less important ideas which are less difficult, and work your way up from there. Okay, so once we've got our idea, we need to know how we're going to sell it. Are we going to sell it on the internet? Do we have agencies that we could sell through, etc.? And of course, we need to know what the cost of this is going to be. And this is going to be a large part of weeks 5 and 6, I think, from memory, where we start to look at the cost of the device. Is it competitive? What is the cost of our competitors out there? And do some market research on the demand, existing solutions, and cost competitiveness. We need to have some metrics in place. How are we going to measure whether our device is succeeding or failing? And this actually brings up a very good point. One of the modern design strategies is fail fast, fail often. And this is based on the idea that, yes, try things out. And if they're not going to work out, identify that very early in the development stage and throw the idea away. In this way, you can try many different things without overcommitting yourself to long-term development. So, fail fast, fail often is an interesting design approach. And this is where the Canvanizer comes in, and the brainstorm, mind maps, etc., where you just throw out a whole lot of ideas, you look at them, are they feasible? If they are, maybe you move on with them. If they're not, you throw the idea out, but you don't rule anything out at the very initial stages. And finally, unfair advantage, key advantage of a certain idea, for example, can't be easily copied, and we'll go through those. The little thing, this particular Canvanizer sheet, it's a very straightforward, small, simple one that we used on our small stop, and it's okay as a basis. We would like to see the Canvanizer submissions in a little bit more detail on this particular one, but we'll get to more of those. All right. Do we have any questions on Canvanizer? Is anyone able to access the web page for Canvanizer?
So you can click the raise hand button, which is there if you hover your mouse cursor over your name in the participants list, and I'll be able to see that and let you know if you do have a question. Or alternatively, if you're having any connection problems, you can type in the chat window. You can choose to type that to everybody, or if you want to send it to me in particular, I can read it out.
All right. Well, I'll continue on. If someone raises their hand, I will stop and Josh will let me know. Okay, so if nobody's having problems with this, great. As I said, it is a very, very handy tool for getting your ideas out and identifying what you need to do in the product development. These will be submitted via EBEX and marked by your fellow students. The reason we're actually having them marked by other students is not that we're not going to look at them, we will, but it's going to be very, very beneficial for you to see how other people have put their ideas together, what they are thinking of doing, how they are going about the particular propositions and how they're going to market it. And that, again, will be useful to you to modify your plan as you go further down the track. So we're really keen on you having a look at others rather than us just marking them and giving you some feedback from one perspective. The best feedback you get is actually by looking at others, seeing what they've done better than you, seeing what you've done better than them, and then combining that into the structure that we'll use in your final submission. So even though we ask that you only mark 2 of the other students' Canvasser assignments, I would suggest if you have time, I would look at a lot more of them to get a better idea of how people have gone about their design process. Okay, so just for your own information, own learning experience, try and have a look at a few extras, even though there is only the 2 that you need to grade. Okay. So moving on, next week we've again make sure you're in your topic team and you posted your idea to the discussion board and provided feedback to others. So make sure you go and have a look at some other people's projects. It will widen the experience, the same as a Canvanizer, give you a much better idea of how other people are approaching it. And this is particularly interesting when we look at the wide variety of people that we have in this course. There's technical people, there's business people, there's people with limited expertise in both areas that know exactly what they want to build. And by posting your idea and then looking at the others and liking the ones you think are really good ideas, it will give you a greater exposure to the way people think, particularly from people outside your current experience. And I think that's one of the really nice things about these sort of courses is you can get to meet people from different environments, very different experience, and very different ways of thinking, and that will help you build your ideas. We've already decided on the web conference group, so that's all okay. WebEx meeting information is now on a tab at the top of each page, so you don't have to rely on the reminders in your calendar. You can just go and click on that and jump into the meetings. And that means you can actually jump into another meeting if you can't make the morning one. Okay, so have a look at the product development videos. Start thinking about a business development plan for your idea. These videos are there as a support. They are not the main way that we are trying to work through this particular module of the course. But they are there to give you the background information you need to be able to structure your business plan and your development in a formal manner, which is going to be required if you ever try to commercialize or you try to get backing from your own company. So watch those videos. If you've got any questions on those, email to the IoT Capstone email, and I will try and get either Todd or Nick along to a couple of the meetings later in the course, so we can actually meet them and have a chat to them. Okay, so final thing there is, in week 4 is to populate your Canvas Organizer template and have it submitted. And this is the first graded assignment worth 10%. Okay, so that's what we've got. All right, so now what we want to do is we're going to try and have lead the discussion. So what we would like to know is how you're going with your project. Have you got the idea sorted out? We're not going to go through necessarily everyone. We would like people who have issues to raise to please raise them. If we're looking at you need to find out where to get some parts, or you want to know how you would access or gather information on a certain aspect, what type of sensor to use. If you're looking at the processing power you need, a lot of you are looking at doing edge processing rather than at the device itself. Have you sorted out the protocols? Now is the time to ask for any information you need on that. So I think if we start off with anyone who's either missing an email, has a direct question on the course itself, and then we'll go into the individual questions, issues that we need for projects. Please don't be shy. We want people to join in.
Yes, Mauricio has a question. Hello, Mauricio.
Yes. I hope you can hear me. Sorry, I have a doubt in my Canvas. I mean, I think that probably most of it is done, but when I was working in the code, as you know, I'm still in the prototype, and I know the steps that I have to follow to have a final product. And I know there's a few things that a lot of testing that has to be done, and the creation of the PCB and other factors that they're going to have a cost. And I was wondering if I should include all those costs of investigation to the product cost, because at the end, if you just remove that part of the cost, then it's going to be below the price at the end. But during this phase, I have to invest for creating the final product. And there's one thing that is killing me here. It's expensive to build the plastic protector. It's really, really expensive. I don't know if it's worldwide, but it's like 50,000 just to make the I don't know how to call it. This the thing that they're gonna try to repeat it every time, and then the repetition of the plastic is really cheap, but the mold is so expensive. So I don't know if I should include everything as part of the project, or it should be split in two different, because that will change completely the game in how I address the market. The market is huge. It's 80 million people as far as I know worldwide. So if I target just 10% of that or less, I think it's going to be okay. But if I include all the investigation and everything, then it's going to be too much money for me. I mean, just for a project school, that's fine, but for a reality, that's going to be complicated.
That's a really good question. So I'm assuming that you're looking at injection molding or some vacuum forming. So tools have to be made to cut the housing to contain the device. Is that right?
Yeah, that's correct. Yeah. That's okay. The so expensive part, and I know I have to get to that point, even though I'm really far away from there. But I know it has to happen. Otherwise, you cannot put it into the market and have a final product. So yeah. That's correct.
What I'd suggest is you invest fast. The first one is you say there's 80 million customers out there for this device. So if your tooling cost is say $20,000 to create the tool, and then what item cost falls to 50 cents each, you work out, will I sell all of these? Assuming I do sell, say 40 million, how much does that cost reflect back into the cost of each item? All right, so if it's really, really worthwhile, and you're very, very confident you're going to get those numbers, then it's probably worthwhile going out and finding an investor to share in the cost risk, etc., to produce that guide. However, if that's not the way you want to go, I would suggest that you can. Josh, you mute someone. I'm getting a little feedback. Okay. I would suggest you investigate doing very small runs and aiming at a small subset of the market and produce the housings via 3D printing. These are really good because you don't get yourself tied into a particular design immediately. Once you've made the die for injection molding, then you're stuck with it. That's what you have to use because it's really, really expensive to change it. If you 3D print, each device is expensive time-wise because they're not very quick to print, but you can rapidly change at very, very little expense the physical design of the object. And you can produce small runs of this, 50, 100 odd devices, sell them into your local market and use the money you gain from that to invest in your final injection molded design. So work on a multi-stage approach, small run, sell enough so that you reinvest that profit back into tooling up for larger runs. Does that make sense to you?
Yeah, totally. I never thought of that, but that's the easy way to go, and it can help me to go on and have a better understanding of the market. And if it really can take off, then I can just move to the other part. But that's a great lesson then later on. Yeah, that's great. And also, I was wondering for the revenue side, at the end of the day, at this point with the talk that I'm pretending to do for the second one, I'm kind of the only one at this point. And if I don't know if you guys like cycling or not, but it's really bad to watch it on TV. I mean, it's a thing. It's a pity. I mean, it's really bad this time. Just look at fights from the 80s; they were so strong, and it's just because the rules. So this is pretending to help many things of that. So the point is, if this is like the only product with these characteristics, should I mark the price of the market, or should I get closer to the other guys that I just have in? They just have a sensor, but the sensor is just like I think it's called Hall effect, just that they touch, which is not calculating the force of the impact. So they're really far away from what I want to do. So the question is, should I put my own price, or should I try to go nearby these guys?
Again, that's something you've got to look at very carefully. If you've got something that is offering a great deal more than your competitors, then you can justify a higher price. If yours is costing significantly less than theirs and does exactly the same job, from a commercial point of view, you would tend to price it close to the competitor's price, less of course, but close to it, to maximise the return on your investment. So you can recoup your development costs very quickly. What will then happen is the competitor will probably drop their price below yours, so you drop yours below them, and you start a bit of a price war. If you go in too low, then people may actually say your device is no good because it's cheap. So you've really got to look at the more holistic view on pricing.
Yeah, I will look like that. And yeah, I mean, that from the canvas, that was my questions. I have any questions about that, but I will let the rest people to speak.
Yep. Just send an email through if you've got other questions, and I'll reply back. And if you don't, and I'll post those answers on the discussion board if they're relevant to, or could be relevant to other people. Just state whether you're happy for it to be shared or not. So they're not sharing anything that is intellectual property of your own.
Correct. Thanks, Professor. I will. Yeah. So some technical questions which I don't think that is relevant to it.
Yeah, just put those in email and we'll get back to you as soon as we possibly can.
We have a question on the chat, private message from Varun. He's having connectivity issues. So he wants to get insights on selecting the database for his gateway. He's considering Raspberry Pi as his gateway device and looking for any help in that regard. His idea revolves around collection of sensors data from agriculture, the agricultural side of things, sensor data.
Okay, Raspberry Pis are great. In fact, any of the Linux-based machines would suit. Probably depends how much data you're gathering and what data rate there is. So that's probably the most important thing to work out to begin with. How often are you sending data and how much data are you sending back to this the central point? Because that will define how much storage you need on the device. Mind you, it's big nowadays. But any Linux-based single board computer would suit, and the Pis, as I said, are very good for this. And then I personally just run MySQL, some open source or close to open source database system that runs under. And that way it can easily be ported to any other platform if you like. So keeping things in the ISO way, probably the best way to go. You can lock these down later on quite easily, but that would be my suggestion. But really look at that amount of data that you're sending and how much data you need to store at the local point.
Mauricio, sorry, not Mauricio, Adrian has a question, also connection problems. I think everyone can see the question in the chat window, but I'll read it out.
Well, I can't.
He has a doubt about the key metrics and the unfair advantage. He understands what they are, but how to recognise as far as possible whether the chosen ones are the good ones.
The key metrics are how you're going to measure whether you're succeeding or not. So if we look at our snail tracker, for example, so we can use this one. It's not showing very well. Anyway, the key metrics are what you want to set as your milestones. So if we look at the snail tracker, this is a nice one I thought. Our key metric will be, are we identifying the snails? So at some point in the process of development, we've got to have some way of identifying snails. So that would become one of the metrics we use. Do we identify snails? Yes. How often do we get false positives? How many times do we get false negatives? And that would be one of the metrics we would use on success. What was the rest of the question, Josh? Good.
The unfair advantage as well. How to recognise that.
Okay, unfair advantage is really the key aspect of your design which nobody else can do. And the unfair advantage of our snail tracker over using snail baits and pellets is we're not hurting the snail. And every other solution kills the snail, and we're not. So that's an unfair advantage that we can use to sell our product. So it's really looking for what differentiates your solution to everyone else's.
Okay, hopefully that answered your question. Yes, he says thanks.
If in doubt, send an email. And we'll answer those. I'm doing emails as soon as I get off this.
And is there anyone else who has a question at the moment? Either on the chat or raise your hand on the participants list.
If not, let's have a little talk about the platforms, how you can develop. Most of us are going to be looking at using sensors. Just to interrupt Josh if we've got anyone coming on. We're going to be using sensors. We're going to be gathering some data. We want to store that and possibly send it off to some cloud storage for processing, display, dashboards, etc. One of the most beneficial things to do when you're at the early development stages like this is to try and keep things as standard as you can and as open as you can. The question we had about using a Raspberry Pi and what sort of database is a fairly good example of why we do this. If we choose a Raspberry Pi and we develop everything using open source software for our prototype and it works out well, we can then look at the cost reduction by producing our own microcontroller, buying a smaller, more secure database, and then transfer everything across to this more compact, efficient, customized version. However, if things aren't going well, and it is off-the-shelf open source, we haven't lost any investment in the design of our own platforms, our own database systems, our own PCBs, etc. So it's always good to start off just using development boards or cheap off-the-shelf material. It may not do exactly what we want. It may be a little bit more expensive than what we want to end up with, but it gives us the flexibility to change things fairly quickly. Personally, my favourite platforms are the Raspberry Pi, any of the Arduino platforms, and another one called Onion. Onion's a really nice IoT computer. It's I think about $9 Australian, so very, very cheap, and you can get a fair bit of I/O on it and has lots of development boards that stack up. So have a look at the Onion Amiga boards. They're actually quite good. But to give you an idea, the Arduino Uno, I think they're just about $90 or something. No, $19. How much are they? I can't remember.
Last I remember, maybe 30 Australian dollars, but Siavash, I don't know.
Yeah, especially. The reason I ask is if we buy a Mega or Uno or one of those type development boards, we're looking at a relatively high cost for a one-off. Whereas when we go to, and I hope you can see this little board. See? Yeah, you know what that is, Savash. This is one we've actually developed here, which is the equivalent of an Arduino, that each one of these boards is very, very, very cheap. It's only $1 or $2. However, the development cost was actually quite high. So we need to have the call to be able to produce a lot of these to reduce the development cost over the product run. And then the main reason we have this one is physically shrinking the size. But if we do anything wrong, we've got to go back and change things and then have another production run. So the cost can be very, very expensive. Whereas if we're just using an Uno and it turns out to be the wrong processor, well, it's very easy just to go and get another one at very low cost in the scheme of things. So using open, standardized development platforms and software is probably the best way to do your prototyping. Once you've got all of the ideas sorted out, you know how you're going to construct it, you know what the requirements are, then you can start moving to your own platforms. Another thing that you do with this is you might go and get a Raspberry Pi 4, nice and powerful, and start to use that for your development. You find out that you don't need all that processing power. When you develop your own, you wind back to what you actually need. So you can work out what the specifications are on the more powerful platform, reduce those specifications, thus reducing your cost when you come to your own production.
I've got a question and a comment on the chat window. And also, I was just thinking a fortnight ago when we last had this group, I don't think Siavash was here. We might just want to briefly.
Oh, he might not. That's good. Yeah. Siavash, please introduce yourself.
Yes, sorry everyone. I'm Siavash. here at Keratin with Ian and Hannes, one of the other instructors. So if you ever had any questions specifically regarding the embedded system, small electronics, choose any sort of microcontroller I'd be the guy to ask. And I might end up missing some of the morning meetings because it's involved in between some of the labs that I'm teaching, but they're on a fortnightly basis, so I'll try to be here as much as I can, but I'll be able to answer email. Just to add to what Ian was saying about choosing a development board, as an example, another example, one of the other approaches was looked at, so I was looking for a specific sensor, and instead of focusing on one device, I found something with an open hardware design, like a sensor tag, or there are these development boards that have a bunch of other sensors on top of them. It might be that you just want to work with an IMU, or you just want to work with a photoelectronic sensor, but if you can find a device that has a bunch of these sensors, the actual cost initially might be slightly more expensive at the inside of a development board, but because they offer their designs as an open hardware and open software, then you can later on, if you are interested, you can go narrow it down to design your own PCB with just one of the sensors, utilizing their open hardware design, and then you can take advantage of some of the open software phone apps that they offer as well. So that's an example of what Ian was just talking about.
Thanks, Sivash. We've got a message from Jerusa saying that here in Brazil, she says she finds hardware similar to Arduino for $5, so it can be relatively cheap.
You can, if you go on to eBay and Alibaba, find Arduino clones very, very cheaply. We were buying some for the Nanos for about $1.50 each. The problem you have quite with these is they don't have good quality control. So you'll buy in, as we were buying 2,000 of these at a time for our first year students, but only 1,500 actually worked. So just got to be a little bit careful with the quality control of some of the clones. Just something to be aware of there. They are very, very cheap, but maybe not the best quality.
Now, I've got another question. I've just noticed Mauricio still has his hand up from before. I'm not sure if it's up from before or he has a new question. I'll just find out in a minute. Sivash, do you have something to add?
Yeah, just I was reminded of something. Another device I might suggest looking into is there's these microcontrollers called ESP32. A couple of our students have been working on. I've been playing around with them. There are many development boards for them. They're not as easy as an Arduino to program, but the good thing about them is they have an embedded Wi-Fi transmitter and being able to transmit on the same actual processor. So they're nice and small. They're fairly cheap. And there are Arduino cores for them, so you can use Arduino's programmer to actually program them. And that's another example. I'll type the name in the chat if anyone's interested in that. So that might be another option if you want to look into something beside an Arduino or a Raspberry Pi and you're looking for something that's become a bit of a buzzword in the IoT scenes. So that's something I've heard good things about as well.
Thanks, Sivash. There's a question in from Varun on the chat asking, will we get any public cloud access in this course for students' use or anything similar to that you can suggest?
At this point, I would say yes, but we may. We're working on it, but I can't guarantee it for this particular course. But what you can do is you can go to either the Microsoft Azure or to AWS, and you get a free number of hours and storage by signing up for one of their trial accounts. With AWS, I think it's 100 hours of processing and a certain amount of traffic. I can't remember off the top of my head what it is. but you can actually get that on your own if you so desire. There's other dashboard type applications which will allow you to have cloud storage as well. One of the things, if it really is a problem, is, and I think I mentioned in this session, when we have an issue with, say, a sensor being too expensive to buy a particular project and we're not sure we're going to need it, and we don't want to invest that kind of money, we simulate it. So in the case of sensors, we would use an Arduino Micro or Nano to provide the outputs that would be sensor outputs from that particular type of sensor. So if it's a turbidity or oxygen level, we would program up a little device to give the kind of outputs we would expect from that sensor. And that can also work at the other end. So instead of using a full cloud system, you could set up another Pi or desktop or any machine that is acting as a cloud service. So you can actually send your data up to what appears from the IoT device's perspective as the cloud, but is actually only a database running on a local machine in your home or office. To switch that over to true cloud wouldn't be a major issue. So you can actually simulate the cloud by having something fairly local. Does that make sense? So use a local computer to act as a cloud if you can't get enough access to cloud resources without any cost. But we never know. We might be able to get AWS access by end of August, but I can't promise it.
The board that Sivas was talking about, he's typed it into the chat window if anyone would like to see the details of that. And, Mauricio, I think you must have just had your hand up because the hand's down now, so there's nobody else at the moment with a question. Now's the time if you've got another question.
Nothing? Okay, well, one of the things we should be looking at too, particularly for those who are using lots of sensors, is start thinking about what mechanism you're going to use to transfer. Oh, there we go.
Yes, you did have a question.
Sorry. I have a question. Yeah, I tried to use the tool to emulate the with software the Arduino stuff with the Tinker card. But I couldn't find the sensors that I was looking for. The sensor for like accelerometer and the heartbeat. I couldn't find those sensors there. It's there because this is like the free version, or it doesn't exist in there.
Josh is actually an expert on Tinkercad, but I would expect they don't have those sensors available. It is really only a small prototype. You can do the same sort of thing. It's through software create the generation of the kind of data you would expect. So have a little subroutine run, generating what you would expect that data to be. The only real way to do this, and we have this with mobile phone development as well, is to use physical devices. So as soon as you get into things like magnetometers, gyros, accelerometers, you really need to be working on the real devices, and they are cheap. I think Savash $9 for a 9-axis IMU, fairly typical.
Yeah, that's thereabouts. They're pretty cheap, especially
they are. I bought it, but I was expecting before bought it. I was trying to do it there, but maybe I did something wrong. But okay, it's clear. Thank you very much.
No, a lot of these, this is the reason you can't go too far with most simulators, is they are simulators. They don't reflect the real world. They have limitations on what you can do with them. They're great for trying something out quickly, but you really do need to go to the physical devices to move to the next stage. Okay. If we're waiting for another question, I'll just mention one of the things you should be looking at, it was raised with the agricultural project. Start looking at the protocols that you want to use to communicate between sensors and back to any edge processing. Once we get to the edge, then we're pretty much on 3G, 4G, 5G, or wired Ethernet, wireless Ethernet. That's not really a big problem. That's got lots of bandwidth. We've normally got power supplies on those devices, so again, we don't have to be power conscious. Getting from, say, a whole bunch of sensors out in a wheat field or cornfield and getting that data back to the edge is a significant issue, and you have to be sure that you're picking the right protocol. So look at the amount of data you're trying to transfer, how much data you are transferring, how often, and the number of devices, and make sure it fits with the particular protocol and distance, of course, the particular protocol that you want to use. So we've had lots of problems with Bluetooth. It's meant to be able to handle 1 or 2 megabits per second, but when we put 10 sensors on the same Bluetooth network, we're lucky to get 60,000 bits per second through because of the interaction on the media. So looking at that fairly early, that will affect the type of board you're using, it will affect the cost of the boards, etc. And also, in some cases, the complexity. Some of these protocols are quite complex. Have we got anything else, Josh?
Not at the moment. There's some information from CFS on IMU devices, one of the most popular ones for those interested. No questions at this stage.
And as I said, I'll be going through emails straight after this to make sure I've answered everyone. But feel free to drop us a line. We want to hear from you. We want to know what you're up to. And in certain cases, if there's a particular matter, I'm the people taking to work out a time. Drop me an email, and I'll send back my Skype details through that. Okay. There's nothing else. We can close off. I'll hang around on here in case anyone has a message that they want to pass through. But thank you. Oh, which instructors do we have today? We had you. I'm not sure if Naz is here. She said she had something.
Yeah. To deal with.
Sasha's there, of course. Hannes has got a lecture.
Yes. Yes, that's it at the moment.
Yeah, David's got morning lectures as well. So. But anyway, if you need them, we can get them in contact with you afterwards.
Yes, no questions at this stage.
All right. Well, thank you, everyone. Thank you again to our Master of Ceremonies. I'll edit this video while I answer all the emails and post it up. Please subscribe to that channel so that you'll be able to get notified when the discussions recordings are. And we shall see you in 2 weeks. Please drop us a line if you need it. Thank you. Bye-bye.
Thank you. Cheers.